So first thing we're doing with log properties is this is really kind of what we're doing today is we're going to solve tomorrow, but today it's more of kind of solving it mentally. And tomorrow we'll dig into it a little bit more later. But the big thing they're asking you right now with some of these log properties that we're going to do is the very first thing they're going to have you kind of work through is something like this. That they may tell you to rewrite it and then solve it. So they're kind of building up to the properties that we're going to have in just a minute. And then once we get to those properties, then we'll show you, what's kind of happening with it there. Okay, so very first thing they're going to have you do is something like this. They're going to have you say, all right, they want you to evaluate or to solve or to simplify, whatever they want to say the word there. Log base 4 of 16 or log of 16 base 4. Okay, now, and we'll show you a trick on this later on, but here's the thought process they want you to think about. That when you have something like this, they want you to think back to like we were doing yesterday. That they want you to think that this is that, and this is what always used to throw me off was that if I had this and they were like, okay, they want you to solve this, you have to think that this needs to equal something. So let log of 16 base 4, let that equal x. And then here's where you're going to kind of go through the rewriting process on this one. Now you're going to rewrite it. So now it's going to be 4 to the x power equals 16. Okay, and 4 to what power equals 16? 4 squared, right? So 4 squared equals 16, so that means your x value would equal 2. Okay, so if they ask you to kind of rewrite and solve, again, when you get here, you're not able to rewrite that because it doesn't equal anything. So what you've got to think about that really equals x. So then you can rewrite it as 4 to the x power equals 16. And then you just think about, okay, what power of 4 will get me to 16? And then you got your number there.
What if it doesn't end up equaling that?
We'll show you how to do it with a calculator then. All right, so for example 2. Got log 72, or log of 1 base 72, or log base 72 of 1, whatever you want to say it there. Okay, and same thing on that one, that you've got to think about that equals x. So then if we rewrite it, it's 72 to the x power equals 1. Okay, and here's where you got to put your thinking cap back on again for this one. 72 to the x power equals 1? 0, right? That anything to the 0 power is 1. So it doesn't, what this is, 72 to the 0 power equals 1. So then x has got to equal 0. So, and that's kind of the thing you want to do, that if you ever have log of 1 that's here, then you automatically have to think that basically your answer is probably going to wind up being 0. Because it doesn't matter what this base is. If it's log 1, it's basically always going to equal 0. Okay, so in this case, and again, this is more of a thinking process. We're going to show you way here in a little bit that you can do these without thinking, but this is more of just a thought process to kind of get the thinking going at this point. All right, so for this one, we're going to go ahead and, again, we know it would be this. We're going to go ahead and rewrite it to know that it really would be that. Okay, and again, their thought process is that once you're here, they want you to rewrite this and solve it. So it's 9 to the x power equals 3. Okay, now if it was the other way around, if it was 3 to the x power equals 9, what would x have to equal in that case? Had to be 2, right? So it'd be x squared. But in this case, your number is getting smaller and not bigger. So you can't square it. So how about, yeah, square rooting it, right? Because if you square root 9, square root of 9 equal 3, right? And does anybody remember what we said if you're doing square roots, what that power would be? I think we talked about it way back when. It's a way back when. There we go. It's 1/2. There we go. So square root is the same thing as half power. So this is 9 to the 1/2 power equals 3. So that means your x is 1/2. Okay, let's do one more of those. And this may be kind of previewing a little bit for what's going on, but okay. All right, so for this one, we don't have a base, correct? So what is the base? Base 10. There we go. So if there is no base, we know it's base 10. And this is really this is the question that's kind of leading up to the big thing we're going to do tomorrow when we're solving. Is that we are, but this is one of those that this is the main purpose of doing it. That if you have this equation here, there's no way you can solve this problem like it is. But you must rewrite it, because if you rewrite it, then the answer becomes crystal clear. X equals 10 squared. There you go. So X is 100. Okay. The rewriting, yes, but not the solving part. Yesterday we just rewrote. Today we're actually kind of solving and simplifying in this case. Okay. Now here's the two big things that we're going to do, and then at the end we're going to show you how to use your calculator on some of these problems to help out. But there are, and these are the log properties that we're looking at. And there's actually two different ways you can go with the log properties. This is one that we're going to expand. And then there's another way that actually when you start solving the problems like what we're doing, we're going to condense. That's the part that's going to make more sense, because with the expansion, it's probably kind of going the other way more than it is anything else here. Okay, and there are three properties we're going to look at. The first one is a product property, power. All right, so if we're doing the log of where B is your base, if you have two things that are multiplied together, and putting the dot in there just to know that it's multiplication there. Okay, if you have to expand, which is probably what's going to ask you to do, you're going to do the log of M, and where you have the multiplication here, that multiplication is going to turn into addition, the log of N. And again, just keep both of them base B. Okay, and we'll actually do some examples with different numbers here in a little bit, but that's kind of the basics for that part of it. So anytime you've got multiplication of two things, to expand it, you take it as log of the first thing and then plus log of the second thing. All right, your quotient property. Well, quotient means divide. So now we're going to have log of, this time let's do M divided by N, base B. All right, and this is hopefully if multiplication becomes addition, division will become subtraction. There you go. So it's going to be log of M minus log of N. Again, the base never changes, so it will stay base B or whatever the base may happen to be. Okay, and then your third property. And that's the power property. And no, it's not he who has the power gets to make the properties. That's a different one. Um, power property basically is this: that if you have something, some expression to the p power, to rewrite it, to get it, to expand it, you're going to take whatever the power is that's out front, and it's going to be multiplied by the rest of the log expression.
So even the base gets multiplied, or the base doesn't change?
Well, it's no, the base will stay the same. You can almost think about it like this: that it's p times the log of whatever it is that we're working with there. And again, we're really going to use that more. These will come in really more to play tomorrow when we solve everything. Today it's more of just practicing and kind of getting used to it, and tomorrow we put it together to actually solve and get the answer for what we're looking for. Okay, so let me give you some problems on those that we're actually going to expand so you can see how this thing gets used.
What's your name? And then so you- Yeah.
Okay, so here we go. So let's expand the expression. All right, we're going to make Emma happy. All right, so for A, we're going to do the log of a squared and b to the seventh, base 5. All right, now in this case, we've got two things. You've got powers of stuff here, but you also, the main thing is it's two things multiplied, that it's a squared times b to the seventh. So the very first thing we want to do is go ahead and separate that into two parts. That's a squared, again, base 5, that won't change, and then plus log of b to the seventh. Again, it will stay base 5. All right, now inside of those, when we separate it now you've got the powers that's here with the a squared and b to the seventh. So then we'll go one more step, take this 2 that's the power here and bring it out front. So it's 2 times the log base 5 of a. Oh, that's the power here. So that power just comes and then drops down there. And then same thing for b to the seventh power. That power will drop and then go out in front and make it 7 log base 5 b. Okay, so if you've got two things multiplied together, it becomes a plus. And if one or both of those things happen to have a power associated with it, that power just drops out front. That then becomes 2 times whatever the log is you're working with.
Wait, is that not the answer?
That's it.
That's just the answer?
That's just the answer.
You
Yeah,
wouldn't go
so-
to 9 log to 5
Oh, that's an A. So if it's that case, then that's all you would do. Yeah, because they're different variables. And that's the answer. Now again, this is just kind of priming us for tomorrow when we start solving and we have to use the properties to solve. Today, we're just rewriting it to make sure everybody's okay with it. And then if you get comfortable with it, we'll check through the homework and it's all good. Then tomorrow we're going to come back in and solve using these same properties. All right, so let's do log base 7. Let's do r to the third t over v. Okay, so you've got actually two different things in this one because on the top part you've got r to the third times t, and then you've got divided by that part. So basically we've got two different things in this one. So very first thing is we've got log base 7, we've got r to the third times t, so that's going to be a plus log of t base 7. So we've got multiplication here, so we're going to put a plus between those two to show that part. And then it's divided by v, which means then with division, that means it's going to be subtraction. And then log base 7 of v.
I think they have probably like
5 or 10 minutes back. So.
Because I think they have like home mode, but I don't know if it's like obviously
Not sure. Should be. Okay, so the only thing left on this one is you do have r to the third power. So we're going to take that 3 and bring it out front to make it 3 times the log of r. And the part you got back here, there's nothing to do with that because, again, they're different variables. So we'll just leave those just like they are. Okay. Now, again, of the two that we're going to do, expansion is probably the least productive, I guess, what we're going to do, because when we start solving, it's the condensing that we're actually going to do that's more useful, I guess you'd say, when it comes down to it. So if they're going to ask you to expand it, you're going to take an expression that's got log written once, and now it's going to be used 2 or 3 or maybe even 4 different times, depending on the numbers that they give to you. When they condense it, but basically for that one, you're going to rewrite using log once. So expanding it is you're going to rewrite a log expression that's got word log once, and you're going to have it written, 2, 3, 4 different times. Condensing is the opposite. Now you're going to take it where you got log written 2 or 3 or 4 different times, and you're going to condense it all down so that you only use the word log one time. Okay, and your properties basically go in reverse for this part of it. So your condensing properties is basically everything backwards. So if you did the product property, that's we're going to have log of x plus log of y. You can see it there. So product property, basically if you've got log of x plus log of y, to condense it, doing everything backwards now. So that's going to be the log of x times y. So we're just doing everything in reverse. So now if you have addition, to condense it, you're going to take the addition that's in between the two log expressions and make that into multiplication. Mm-hmm. Okay. And then your quotient property, you have log of x divided by log, or log of x divided by y. Oh, wait, sorry. Try it again. Taking an inverse here. So you have log of x minus log of y. There we go. Then we condense those two things together. It's going to be log of x divided by y. It's going backwards. I gave you the answer while I was thinking about going the other way. Okay, now the one that's really not condensing, it's more of just rewriting it, because to me the whole point of condensing is that you bring it back so it's one log expression. When you do the power property, it's already just one expression. So this would be where you have some number times the log base b of m. Okay, and it's already there just once. So again, condensing is just doing everything the backwards expansion. So for this one, log base b of m, and this number that was out front now becomes the power that's going to be on the end. Okay. Now, and again, these are the ones we're actually going to use more of tomorrow. But we did the expansion just to kind of make sure that you're okay moving back and forth on these. But again, condensing is really where we're going to be more helpful when it comes down to when we're solving tomorrow. Tomorrow we're just going to blow the lid off all the solving. Sorry, everything we're going to do, we're just going to solve all day long. And we're going to use all this stuff we've done the last 3 days to kind of get us there. Okay, so for these, we are going to condense, and then we're going to say solve if possible. Now, the big part on that one is when we're solving it, this is the part you would not use a calculator on. This is the part they're saying, all right, if we know there's a property that we've got that we can do, then that's what we're kind of looking at doing. Because in a second, we're going to show you how to get some answers with a calculator that you don't have to think, which, and I hate to say that you don't have to think, but I mean, that's really what it is. You don't have to think. You just punch it in the calculator. All right, so let's go log of 5x plus log of 3. Okay, and then the problem in this case, if you're asking you to condense, I don't know if solve is the best word. How about simplify if possible? Because we're not really solving it, we're simplifying. Because there is right now that it's not equal to 2. There is no equal sign at the end of this one. So this one, we're not really solving it. We're going to simplify it, I guess is what we're doing. Okay, so log of 5x plus log of 3. There is not a base, so you don't have to worry about rewriting it with a base of any kind. So just leave it just like it is, because we're going to assume that case the base would be 10. But because it's plus in the middle, that means that we need to take these two things and turn into multiplication. So that's 5x times 3. So it's just 15x. Okay, for this one, let's go 6 log base 2 of x minus 5 log base 2 of y. All right, so we've got a couple of things. That if it was just this part, we would take the 6 and move it up top. Just like if it was this part, you'd take the 5 and you'd move it up top to make it a power. So that's kind of our first step we want to go with there. So it's going to be log of x to the 6th minus the log of y to the 5th. Okay. And then because, and kind of here's what it comes down to. Some people are like, well, how do I know if I need to do the power part of it first or need to do the exponent part or the other part of it first? Basically, you need to have log of something minus log of something. If you've got this 5 and 6 in the middle, you want to kind of get rid of those things first so that you just have log of something minus log of something. You do not need a coefficient there in front if you want to kind of think about it that way. You got to get rid of the coefficients first. Okay, and then last thing, I'll put this slide over here at the end. Because it's subtraction, it's going to be the log base 2 x to the 6th over y to the 5th. And that would be our final answer there. All right, let's go through a few more actually here. Let's go with 2 log 6 and x for the base minus log 9. Okay, so again, first thing with this one is you've got this 2 that's out front here, so I need to make that log of 6 squared. And since you've got 6 squared, you can obviously go ahead and make that out to be 36. So this really is the log of 36 minus log 9. And because of the minus we've got here, it's 36 divided by 9. And 36 divided by 9 is 4. And that's where the condensing comes in to make things a lot easier, because that is a lot easier than that if we start looking at stuff. Okay. And that's kind of the whole purpose of condensing, is trying to get it down to the point of simplifying it as much as you possibly can to get it to where you've got, an actual number that's there. All right, let's do one more of those, and then after that, we'll show you a couple other little things we got to mix in here. So let's go to log of 32 plus log of 2, and we're using base 4. Okay, there are no powers. So it's just log of something plus log of something. So to bring these two things back together, we're going to do 32 times 2, which would be 64. Okay, now, and here's where the simplifying part kind of comes in, because this part back here was pretty easy. We had 36 divided by 9. No big deal. When they get to this part, if you get down to the end and all you have is log of 2 numbers, this is the part they want you to say, okay, if I have that, could I actually simplify this thing anymore? Does this actually equal some easy number? So if you kind of think about it that way, just 4 to some power equal 64. Because we know 4 squared is 16. 16 times 4 is 64. So 4 to the third power equals 64. So then basically our question mark is 3. So if we have this thing, this log of 64 base 4, that actually is just 3. So that answer is just 3.
There wouldn't be a log or anything.
No, there would not be a log in that case. Because if we take, and that's kind of what you want to look at, is if you get to the end and you have log of, and you have 2 numbers, then you can actually simplify that down and get an actual answer off that one. Now, if we had an X in there like this one, you couldn't do anything with it. But if you have log of just 2 numbers, then you want to try to simplify and see what you can get there. Okay, now, and it almost seems, I don't know if I'd say mean or what we're going to say here. It almost seems like a cheat to show you this one, but we're going to show you how to use your calculators. So if you don't have a calculator, you need to grab one real quick. Go ahead and grab a calculator real quick. Here's how you get to use your calculator. Now, one other thing, when you're doing the calculators, if you notice, and all the calculators will be similar. The only thing that's going to be different is, yesterday we were talking about it, that with the Casio, it's a shift key. With the Texas Instruments, it's a second key. It's still basically that they're all the same thing for this one. That when you're using your calculator, when we're talking about the log button that's on here, the log button uses base 10. So if we had something that we were, if we had a problem that was just, find log of 2, you could just push log, hit 2, and it's going to tell you what your answer is, as you can see through the glare. So anytime you have the log button on your calculator, it's always going to use base 10. And where we want to be able to do something like this problem back up here is what happens if we have something that's not base 10. And we're going to show you how to use your calculator for that. Okay, now the other thing we'll do, and we'll talk more about this tomorrow, the LN button, it's right beside, and it's almost always right beside, right underneath, somewhere right near the log button. You see this LN button? It could be LN like that. It could be LN like this. A lot of times they'll use it in script where it's LN like that. Just realize that that's all the same thing. Some people, yeah, some people try to say it's an IN because a lot of times it's written that way. I'm like, no, it's LN. Because some people do their homework like every time I pushed it in, it was wrong. I'm like, well, because it's not IN, it's LN. So make sure you're using LN when we start doing some of this homework. That when we do the LN button, and we'll talk more about this tomorrow, uses base E. And E is one of those naturally occurring numbers that it's kind of like pi. It just sort of happens with circles. E is one of those numbers that when you start talking about money and exponents and other things, it just kind of naturally happens. So it got its own special thing. And E is roughly equal to, and you can actually put it in your calculator here. If you do E to the first power, E is 2.7182818281828, and it just goes on and on forever. So E is roughly 2.718, if you want to think about it that way. Yeah, and if you need help with the E calculators, I'll help you out that here in a little bit because every one of it's a little bit different, and it's just a matter of figuring out how it's got to be used for this part. Okay, so here's what it is. Here's how we do this thing. It's the change of base formula. And this is what we're going to do so you can actually use your calculator, that if you have a problem like this, besides thinking your way through it, because there's going to be times where you won't be able to think your way through it because the answer is just not, or the answer is there, you just don't know what it is. It's going to be like, 5 to the x power equals 17. And you're like, I don't know what that is because it's, 5 squared could be 2. We know it's 2 point something, but we got to figure out exactly what it is. So here's what it is. Basically, if you have the log of some number and b is your base where the base is not 10. To be able to use your calculator, you're going to do the log of that number, base 10, divided by the log of the base, also base 10. And then from there, because it's base 10, you get to use your calculator. Or if you're Doofenshmirtz, you get to use your calculator. Okay, so sorry, still got Halloween going there. All right, so if we take the problem we had back here with this one, we'll show you how this thing would work out here. But that was using our brains. Now we're going to get to use our calculators. So we're going to do the log of 64 base 4. So if it says use and a lot of times it may ask you to rewrite it first and then tell me what the answer is. So if you rewrite it, it's going to be the log of 64 divided by the log of 4. And a lot of times in those cases like that, they ask you to rewrite it first. They won't necessarily make you rewrite it with base 10 because if you write it like this, we're assuming that it's going to be base 10. And then from there, it's all calculator. So now we're going to do the log of 64. Make sure you close off, and this is kind of going back to one of those times. Make sure you close off the parentheses. And then divided by log of 4, make sure you close off your parentheses. And then, boom, there you go. So when you do these, when you use your calculator, it's going to do log of, it's going to give you this parentheses. Make sure you close off the parentheses around the log of 64. And then divided by the log of 4, and then make sure you close off that parentheses. Okay, now if you have the Casio calculators, you can put it in 2 separate fractions, and it actually has a button on there that even makes it even easier than that. But if you're kind of writing it out, it'll give you the fraction button, and you can separate out and see it. But with the Texas Instruments like these, you have to kind of rewrite it as the log of the first thing. Make sure you close off that parentheses, and then divide it by the log of the bottom number or your base. Okay, so here's where everybody can practice a little bit. So that was example 1. Example 2, let's go with log 81 base 3. Okay, now some hard problems won't ask you to rewrite it. Some of them will say, just tell me what the answer is. But there may be some problems on the way. There may be some test questions that I may ask you, okay, rewrite it first and then tell me what the answer is. So if you have to rewrite it using the change of base formula, that's log of 81 divided by log of 3. Okay, and everybody punch that in your calculator real quick and see what you get. Anybody get anything yet? Everybody get 4? Okay, anybody not get 4? Everybody good?
Hold on, so. 3. Okay, so for the example you gave us last time, if you didn't use
Actually, this, that if you take this one and do like we did before, this is 3 to what power equals 81 if we were rewriting it. And if you go through your powers of 4, it's 3 to the 4th to get 81. All right, the other thing I want you to do with this one is instead of using the log button, everybody use your ln button. So now we're going to do the ln of 81 divided by the ln of 3. So do ln and see what you get. And again, ln should be right beside the log button. I'm going to slide this over so we can see better without the glare there. So ln is right here underneath the log. So we got ln of 81. Same thing. Make sure you close off the parentheses and divided by the ln of 3. Same answer. So it doesn't matter which button you use. You can either use the log button or you can use the ln button. You will get the same answer. Now you have to be consistent. You can't use log one time on the top and you can't use ln on the bottom. You have to use ln in both, or you have to use log in both. You can't mix and match.
in this case, well, if you use log and no parentheses, you get 0. In this case, if you use ln and no parentheses, you still get 4.
All right, one more. And this one, this is one of those problems where you would have to use your calculator because you cannot get this one unless you're just an absolute brilliant genius. You know, log base 2 of 5. Or log of 5 base 2. Okay, because if we were thinking about this one and rewriting it so that we had log base 5 of 2 equals x, this would be where you're doing 2 to the x power equals 5. And if you can tell me what the number is just off the top of your head without using a calculator, then you're just, super genius kind of thing.
Off the top
Yeah.
of my head, 2.32192809.
Yeah. So that's log of 5 divided by the log of 2. Or again, you can do ln because either way is fine. That would be one of those where you would have to just check and see what the book would tell you to do. Probably, let's go to thousands. So 2.321, that would round that up to a 2.322. Okay, and that's the main reason that we use the change of base is that when these things don't work out to be a number we can do, that's kind of where we have to have change of base form.